So this main scenario of the session is to identify all the reactions that you have in organic chemistry. Tomorrow, I'm going to prepare another worksheet where you have two steps, not one step. So it will be, for example, going from ethene to propanoic acid, or ethene to propanitrile, where you're going to see that you need at least two steps. Of course, whilst there are a lot more possible reactions, you're not gonna have that many more reactions simply because most of them will repeat. You're gonna see a lot of patterns. Once you know how to go two steps, you will be able to go 3, 4, 5, 6, 7, 8, 9, 10. Doesn't really matter. Once you go more than one, you're using the same technique. Now, I'm not gonna do the mechanisms. Okay, the mechanisms, I think this morning's videos were fine. So just if you have a problem with the mechanism, just send me and ask me. So I'm gonna start propane plus Br2 the direct. It's no reaction. Propane plus Br2 in UV light. I realized after I sent it, it was 6 in the morning when I sent them this morning. I didn't feel like sending it again. I had already found another mistake and deleted it. But propane plus Br2 in the under UV will give bromopropane. So A. Oh, and for these, ideally, you do write the formula, not the molecular formula, okay, the structural. And we're gonna do all of them. Now, if for some reason I am still going at 230, I might have to cut this a little bit short. Okay? If I'm still going at 230, I might have to cut this a little bit short simply because I have rather written at 3. B, B and C, complete and incomplete combustions. So for these, again, by the way, part of the exercise is writing the equations properly. So pentane, methylpentane, for both plus O2. So for the first one, it's gonna be simple. 6CO2, 7H2O. Okay, this means there is gonna be 19 on 2O2 for complete combustion. For this, I can write 5CO2 plus CO plus 7H2O. Nonetheless, it's incomplete combustion because there is a CO. Some people will decide, I want 6 COs. It doesn't really matter. As long as you have some CO, it is incomplete combustion. Even. And even if you wrote carbon instead of CO, it's also correct. Incomplete combustion means that you're not making CO2 only. D1. So these are the addition reactions. You have propene plus hydrogen to give you propane. This is the simplest addition reaction, nickel 140 degrees Celsius. Bromine to ethene at room temperature. You have hydrogen bromide to propene. Here you have to follow Markovnikov's rule as well. It's a Markovnikov's rule. Sometimes it tells, sometimes it doesn't. It's always assumed you're gonna follow Markovnikov's rule. Unless he tells you otherwise. But the hydrogen should always go on the carbon that has most hydrogens. Steam to ethene. This reaction, I normally find it quite funny that a lot of students write the intermediate with H2SO4. As far as I'm concerned, in this syllabus, it's never written that you need to know the intermediate. Concentrated sulfuric acid to ethene. So this is the first step of the previous reaction. I've written it, I've edited it just to show you that you might use it. Okay, so it is HSO4 minus, that's added, and bromine water to propene. Here you're gonna have hydroxy, bromo, ethane. So you're gonna form a halogen alkane and an alcohol. This only happens if it's aqueous. Alkenes can also be oxidized. You have ethene, so this is E1. If you want to write the oxidizing agent, you write plus oxygen. And this gives the diol. If you want to try and balance it, KMnO4, or better still, MnO4 minus will give MnO2. This is one of the rare cases where it doesn't give Mn2 plus. 2, it's the same thing. This is for most of the reactions. I actually gave you 2, just I know that you love these, you enjoy them, and therefore I did not want to spoil the fun for you. If 1 is so much fun, 2 is even better. Who's better, man? 3 and 4 were ozonolysis. So for these, it's important to first and foremost draw the molecules correct, and then you're gonna get propanone and ethanol. For the second one, it's gonna be similar, but instead of ethanol, you're gonna get methanol. And page 1 is already done. Look how efficient we are. 1 down, 6 to go. Next one is polymerization. Now for these, I'm gonna first and foremost draw the monomers.
Sir,
Yes,
for the first one, if I put the CL on the bottom right,
doesn't matter.
okay.
As long as when you draw the monomer or the polymer, you have 3 hydrogens and 1 chlorine. It doesn't matter.
So even for the fluorine, the second one, it doesn't matter where you put them.
That it does, because you need 4 fluorines.
Okay, never mind.
But for the first one, no.
It doesn't. Okay, thank you.
Think about it like this. If I put you upside down, are you still Justine?
Yeah.
Okay? Um, so, doesn't matter. Hello, Amy.
Hi, sir. Sorry, I'm late.
It's okay. So, polymerization. Now, polymerization. You can have any double bond. The double bond opens up to form a single bond, and you have the continuation of the polymer. For all, irrespective of what is with the group. Okay? Now, celebratory recording. Ethyne. Ethyne. It's a bit of fun. In fact, when I was doing the questions, I actually first skipped alkynes. I was like, but wait. Yes, they're different. But are they that different? So I decided, you know what? Give it to them as well. And I went on and actually wrote for ethyne. It was short-sighted, Emma, because I didn't realize I have to answer them then. So if I have nickel, that was always going to be full hydrogenation. Nickel will hydrogenate any double bond, or better still here in the pi bond. 2 ethyne, and it's telling you with 1 equivalent of bromine. So this is not about having a catalyst or having, I know that a number of schools tells you the catalyst have to be this or the catalyst has to be this. It's just 1 equivalent of bromine.
Jekk tikteb CHBr, CHBr tajba.
طيب. I'm just drawing the structures here. If I have excess bromine, so it will be 2 Br2, then I'm gonna have CHBr2, CHBr2. Issa jena I prefer to draw them. So but again, it doesn't really matter where the bromines are as long as you have 2 on each carbon, the examiner will be happy. I will be happy. Did you try these things? ethyne with hydrogen chloride and ethyne with excess hydrogen chloride. Again, same thing. So I told you these are fun. But these are the same things, the same reactions as alkenes. It's just that you can have two reactions instead of one. So that is one equivalent. This is known as two equivalents. Now some of you might ask, why is it that these are at 90 degrees and these are not? This is the actual shape, this is how we normally draw them. Both are correct. If you were at university doing chemistry, I would probably advise, listen, maybe you should draw them like this, like the actual structure. But we're not at university here. Therefore, be free, be happy, and do them as you wish. Hydration of ethyne, H, and this is literally CH, double triple bond CH plus H2O to give CH3, C double bond O H, and this you need H2SO4 Hg SO4 less than 60 degrees Celsius, and this reaction is known as tautomerization. It's a tautomer. To close off alkynes and as such close off all of aromatic or of hydrocarbons, you have the reactions of terminal alkynes with silver nitrate and copper 1 chloride. I am not entirely sure about what the white precipitate is. Let me tell you what the compound of the white precipitate is. Just to be safe. Mela. These, I'm wrong. That minus and Ag plus, that minus and Cu plus. Issa, it might degrade as I was gonna tell you, but this is the one that you need to know. I'm glad I actually checked it out. Now, combustion and oxidation. Alkynes have one of the strongest combustions that we use. Do you know where we use alkynes? Where we use actually ethyne?
Allora fai un 6.
We have 5 because it's O2. So we have 5 oxygens here, right? We use it in welding. So this is used to actually melt two pieces of metal together. A weld is literally you melt two pieces of metal together, and once you melt it, then you let it cool down, and they will fuse together. So a good weld is one where there is complete mixture of the two metals that you need to do at a joint. Now, we're actually going to speak about alcohols. We're going to start with ethanol. So this is K, okay? Plus sodium. And you have propanol plus potassium. In both cases, you're gonna get the salt. I'm using the halves instead of actually going and using everything. I'm doing everything times 2. It doesn't really matter. So if you wanted to, you could have had 2CH3CH2OH plus 2Na to give 2CH3CH2ONA plus H2. It's the same thing. Then we also have some substitution reactions. All of the next 4 reactions are reactions in which, okay, you are going to substitute with a halogen and you need to know the products as well. Amy, do these ring a bell? They should all ring a bell, eh? Mux jingle bells, that's a different kind of bell. PBr3 is the same as PCl3. So you're gonna have a Br instead of I'm not sure if it's gonna give H3PO3. And to balance that, you need the 3. This is the same thing with PCl3. PCl3 will need to give the acid. Okay, POCl3 is a solid that precipitates that doesn't react with water. POCl is what you would have, would be very reactive. So it ends up forming H3PO3. This is another halogenation one to add chlorine, and this is very good because you don't have any solids. These are all gases, they can remove from solution. And the last one is the use of HBr. It doesn't look like HBr simply because you have the acid, so it's Br minus to give CH3, CH2, 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 Br plus O minus, OH minus, sorry. This is also a substitution. So these reactions are substitutions. By the way, I will take a break probably when we reach Z or thereabouts. Okay? I will take a break just before we finish aldehydes and ketones. I think that would be halfway through. Just to go and have some water. Oxidations of alcohols. M I'm gonna use the correct oxidizing agent here because it didn't give you an oxidizing agent. The difference between reflux and distilling. In reflux, you are boiling. During distillation, you are actually collecting it. Okay, so distillation, you don't allow it to boil. Oh, sorry, you don't allow for further oxidation. Whereas in reflux, everything is in the flask, the oxidizing agent, you keep on adding, and you end up with a full oxidation. And propan-2-ol can only be oxidized to the ketone, and therefore there is no need to be careful with oxidizing power, and with whether it's reflux or distill, might as well just go all out for it, use the strongest conditions possible, and you'll get your final product. 2-methyl propan-2-ol will not react. That cannot be oxidized. Okay? 2-methyl propan-2-ol cannot be oxidized. Simply because methyl propan-2-ol is a tertiary alcohols, and tertiary alcohols cannot be oxidized. Then you have the dehydration of alcohols. Alcohols can be dehydrated to either alkenes or ethers. So the same alcohol can form either the ether or the alkene. And this all depends on the conditions. Both need H2SO4 concentrated. This happens at 180 degrees. This happens at 140 degrees. So you might tell me, Mase, he gave at 170 degrees. It's the same thing. 180 is more favorable.
plus H2O.
Pala product. If you're balancing the equation, you write the water. If he's just asking you for the organic product, there's no need. O is esterification, and here you have two reactions. So you have methanol. This is a very cheap alcohol. Do not mix with actual alcohol because you'll die. It's very poisonous. With CH2OH, this will be an equilibrium reaction. And for this, you need H2SO4. Normally, you will also heat a little bit. The second one, it's ethanol. With ethanol chloride. This reaction is not in equilibrium. And therefore, this reaction is not in equilibrium, and therefore, you can very easily do this. Then you have a reaction that I know is a favorite with all of you, the iodoform reaction. So, CH3CH2OH plus NaOH in the presence of I2 to give CHI3 plus COO. plus HCOO minus. Okay, so this will always produce CHI3 for the methyl, and what's left becomes the carboxylate. The second one, propan 1-ol. Propan 1-ol will not react because you need to have a methyl group available. Propan 2-ol will react. Okay, now we're going to halogene alkanes. As you can see, it's not a lot of reactions for each chapter. Huh?
Like,
But if you are struggling, do not try to learn all the reactions. Today, try to finish the reactions for alcohols. Tomorrow, for halogen alkanes. The day after, for aldehydes and ketones. Yes, you don't have that many days, so you have to actually eat some pastazzi. But the reality is, not a lot of reactions. There's plenty of time. So, over the weekend, I will change my tone. And on Tuesday, I will be even tipo ispa li żammi għadha. But for today, there's plenty of time.
ġviri, l-motik, mux t-muru ħazin, imma mux nġibu għal tajjeb. Sar eżempju, naqbat eżempju, n-mot nejt il-lum eżempju għamela l-rolls u ħarġin għal-kings, nerġa għamilom.
Yes, listen. Some of these reactions are very specific, like the iodoform. It was never meant for you to get all of them correct. It was meant for you to get 80%, 85, 70% correct. But you're building up on what you got to correct. Issa, be careful. And this is important. That you are getting things correct. Would be more worried tomorrow than today. Okay? Tomorrow is going to be more challenging. At the same time, you should actually start to find your bearing. You start to see patterns. On Wednesday, even more so. Because on Wednesday, you're going to have 3 reactions, 3 steps rather than 2 steps. So this is 1 step. Tomorrow going to be 2 steps. The day after going to be 3 steps. 3-step reactions, they will repeat, and you're going to start to realize that, wait, all the reactions, with what I know, all the reactions have to follow certain steps. Bil-force. I will think about it tomorrow. Q. So, this is the formation of the alcohol. It's okay. It's okay. Issa here, I never asked you about the mechanism. Because here, all I care about is the product. But of course, these two, they are both substitution reactions, but the two will actually have very different products. This reaction here is the reaction of the nitrile or the cyanide, and this is very important because you are increasing the carbon chain. And with ammonia, this is called the bomb. It's actually very dangerous because you're using high temperature and high pressure. And this reaction will actually continue to react to form secondary, tertiary, and quaternary amines, which might not be what you want, but it will happen. Sealed tube. I wrote sealed tube because he actually gave you sealed tube in the question. And if I have a methoxide, okay, so if I have an alkoxide, an alcohol that has lost a hydrogen or an H plus, I would be able to form ethers and that would also give an ACl. Elimination reactions, 2-bromopropane, there is only one possible product here. Remember, if you can get more than one product, you have to draw all the possibilities. And for the second one, 2-bromo to methyl butane, this you're gonna have two possibilities. So you should actually try and write them both. You can either have a terminal let's do it. Or an internal. Okay, so two possibilities, because you can either lose a hydrogen from here or a hydrogen from there. With metals, you can react to form either the Wurtz reaction or you can form the Grignard reagent. Bromobenzene, this is a reaction that you might not have seen because we always do the Grignards with a halogen alkane, but it behaves the same way. Okay, so bromobenzene or iodoethane, the Grignard will be formed where the magnesium will insert itself in between the iodine and the carbon. 2-bromopropane, I chose this on purpose because I am a nice human being. For this, you actually need to write the twos. Okay, and this is going to be a dimerization through the central carbon, because that's where the halogen bond is.
ġifiri hemm fuq xuxin ġeja. Issa, dik maquda ma fuq xuxin.
Eżatt. Then, Rates of hydrolysis: 1 chlorobutane, 1 bromobutane, and 1 iodopropane with silver nitrate and ethanol. Since iodine carbon bonds is weaker, iodine is a larger atom, therefore its bonds will be weaker. Whereas chlorine is the smallest halogen that you actually study, therefore it would have the strongest bond. Therefore, iodobutane would react the quickest, chlorobutane would react the slowest. Remember, bond strength is proportional between bond length. There's a proportionality between bond length and bond strength. The bigger the bond, the larger the bond, the weaker the bond will be. The easier it is to actually remove it. Nucleophilic additions. I'm gonna do till AA. Okay, I will finish most of aldehydes and ketones, and then bit of a break for me and possibly for you. Most importantly, for me. I mean, propanol with hydrogen cyanide, U. Like الموبايل. This forms a hydroxynitrile. Here, you should note that you're gonna have an introduction of a carbon, but also an addition of a functional group. Very important. Increasing the carbon chain and also introducing a secondary functional group. For this, we are also increasing the carbon chain, but the increase in the carbon chain is a little bit more subtle, because at this point, the longest chain is still going to be 3 carbons. It's just that there's going to be a methyl group. For oxopentanoic acid, this seems a little bit stranger, but pentanoic acid is going to be this. The 4-oxo means that on carbon number 4 there's going to be a double bond O. Carbon number 4, you have to start counting from the carboxylic acid. So it's 1, 2, 3, 4. لا. رحت نمشي سوا. هونيك. I went to a different page. Apologies. No. I skipped, I think, 2 pages. Ethanol with sodium tetrahydroborate in aqueous methanol. So, ethanol plus NaBH4. This is a reducing agent, just for aldehydes and ketones. Butanone with LiAlH4 is going to be the alcohol, again, also a reducing agent, just the fun of life. These are quite nice reactions, because you can see the bubbles forming, you can see it react, and it's a high yielding reaction. Okay? Then 2,4-DNPH, it's also called Brady's reagent, but he told you that. So I'm gonna give the products for these. 2,4-DNPH, 2,4 to 4D NPH is this. Okay, so when it reacts, it forms a double bond, so CH3. This is with ethanol. And this is with propanone. Issa, distinguishing between aldehydes and ketones. Now, to distinguish, normally we use oxidizing agents. So propanol with tolerance reagents. So this propanol is this molecule where it's oxidized to CH3, CH2, COOH, and the Ag plus is reduced to Ag. This is why it's called the silver mirror test. Because you see, literally, you form literally silver. Okay, and to clean it, you use nitric acid, concentrated nitric acid, because you can oxidize it again. Otherwise, it's very difficult to clean. In fact, sometimes they give you the test tube to take it home, because it's more worth it than use nitric acid to clean it. It's cheaper. When they buy it in bulk, it's a few cents. Nitric acid, a bottle of nitric acid costs like 30 to 40 euro. Propanone with tolerance reagent, this will not react because ketones are not oxidized. Ethanol with Fellings or Benedicts. So ethanol is oxidized to ethanoic acid, and that is CO2 plus being reduced to CO2O. And the last one is propanol with acidified potassium dichromate. So propanol is the same reaction, but this time the oxidizing agent is different. It's MnO4-. These can all be given in the lab. You would need to balance them, and you would need to do the half reactions using redox. So for example, for the first one, you need H2O here, plus, I believe it's 2H plus 2 electrons. This one will be 4H2O plus 8H plus 5 electrons. The one on top, you multiply by 5. The one at the bottom, you multiply by 2. And you add everything together. I mean, it's not the most difficult, but you need to do it. You need to know it. Again, these are the kind of questions that you need to know. I'm gonna skip X. This is the same exact as the one that we've done for alcohols. Okay? But remember, for alcohols, the first step is to oxidize it to the aldehyde or ketone. Y is the Grignard reagent. So methanol plus CH3MgBr to give CH3CH2OH. I'm giving the product after hydrolysis, okay, not the intermediate. The intermediate, I think I've shown it in one of the mechanisms. for the Grignards, or I discussed it when I discussed the videos this morning. Ethanol plus CH3 CH2 MgBr to give and propanone so propanone will always give a tertiary alcohol. Methanol is the only one that gives a primary, okay? And any aldehyde apart from methanol will give a secondary. خد وصلصة.
إيه.
Z Z is propanone with PCl5. This is the addition of two chlorines. This is first nucleophilic addition, that is nucleophilic substitution, plus PO Cl3. In fact, this does not emit white fumes of HCl. This is a test to differentiate between alcohols and aldehydes or ketones. And then we have the reductions of aldehydes and ketones with either H2, NABH4, LLIBH4. These reductions are all reductions. Okay, so propanol, propanone, propanol, and butanol. I'm not gonna draw the propanol twice. Okay, this will give the alcohol. This will give the secondary alcohol. And this will give the secondary alcohol. So aldehydes give primary alcohols, ketones give secondary alcohols. But the reductions, whether you use H2, NABH4 or ALH4, will be exactly the same.